write the equation of. So go like this, go like that. And let's say we have a graph that looks like this, a polynomial like that. And put a point right there, put a point there, put a point there. Let's say this is at x equals minus 4. That one is at x equals -1. That one is at x equals 2. And let's suppose that you have a random point up there at 1, 3. This level difficulty you can expect on midterm 2. And it's going to look just like this, with the directions saying write the equation of. So here's how I would approach this problem. I would make a list of all of my x-intercepts. X equals -4, x equals -1, x equals 2. Make a list of all your roots. Now, go to your first equation and then add the 4 to the other side. So it would say x plus 4 equals 0. Add the 1 over to the other side. It would say x plus 1 equals 0. And then subtract the 2 to the other side. It would say x minus 2 equals 0. And then I can use some red parentheses to put parentheses, right? To put some parentheses around these factors. We have created factors. So what you want to do now is write all of these factors side by side. Now, the only thing left to find is this mysterious blue coefficient in the front of your factors, which you can call a. So the only thing left to do is to find the value of this number a. It's probably going to be a fraction or a decimal. Let's find it. Once you find a, you put a there and you're finished. So here's how you can find a. Use the point that's just, it seems like it's just a random point on the graph. Use that point and plug in its coordinates in for x and y. That reveals to you the value of a. So for instance, 3 would go in for y, and that number 1, that would go in for all of the x's. So let's try this out. So 3 goes in for y, a stays a, and then all of the x's, all of them become 1. So now let's see what this is. So this would be 5, this would be 2, and this would be -1. So this is 3 equals a times 5 times 2 times -1. These are all being multiplied. And that looks like it's going to be -10. So let me go up here. We have 3 equals a times -10. And so if we divide, you want to use division. If you divide by -10, a has been found. It's -3/10. So that a value, you would put right there back in for the blue a. So -3/10, that goes in for number a. That would go in for a. And so our final answer, if I just erase this here, our final answer would be -3/10 in for a, along with all of your factors. Done. End of story. Final answer out the door. That equation controls that picture. And you could always check on Desmos. You type this into Desmos, it will look pretty much just like that. It'll cross through these 3 points there, and it'll contain 1, 3. Let's do one more problem because this can be a little trickier. So one more example. The same goal. The goal is just to write the equation of. So let's say we have a shape that looks like this. Let me go to my marker. Let's go there. Like that. And then let's say the graph, let's go blue here. Suppose that the graph looks like this. Like that. Put a point there, put a point there. Let's say this is x equals -4, x equals 3, and you have a point right there at minus 1, 2. All right, so same idea here. Go x equals all of your x-intercepts. So here I have two x-intercepts. So this would be x equals minus 4 and x equals 3. And then move those numbers to the other side. So this would say x plus 4, and this would say x minus 3. And then put some parentheses around your factors and put your factors side by side by side. Here. Now, you do want to find a, but there's something you have to remember first from our meeting last time. Remember multiplicities, multiplicities of 1, 2, and 3. Last time we met, don't copy the red, just watch. We said things about multiplicities. We had multiplicities 1, 2s, and 3s, where here, that looked like a multiplicity 1. This appears to be a multiplicity 2. This one looks like it's a multiplicity 3, and this looks like it's a multiplicity 2. We're going to limit it to 1s, 2s, and 3s, nothing beyond 3s. So based on our graph up here, if you look at this graph, do we have multiplicities 1s, 2s, and 3s? What's going on? So this one here, that looks like a multiplicity 1, but this one there, because it bounces, because it deflects off the x-axis, that looked like a multiplicity of 2, which means that its factor requires an exponent of 2. And which is why in the previous problem, we didn't have to worry about that, because if you look at your picture in the first problem, everything was 1, multiplicity 1. All of them were multiplicity 1s. And if it's a multiplicity of 1, like right there, you don't have to put it because it's just a 1. So you don't have to put it. So now that we have the multiplicities in place, now let's find the value of a. Let's find the a value. So where's that random point we have? There it is. We have minus 1, 2. Plug minus 1 in for all the x's and plug 2 in for y. So minus 1 for x and 2 for y. So there, go here. There, minus 1 minus 3 squared. That's going to be 3. And that's going to be 16 because it's negative 4 squared, which is positive 16. So this is 2 equals a times 3 times 16. So that's going to be 48. So 2 equals 48 times a. And if you divide, a equals 2 over 48, which reduces to 1/24th. Yeah. So that would be our final answer. 1/24th would go back in for a right there. So we have a becomes positive 1 over 24. So you can expect a graph on the midterm where you might have a multiplicity 1, 2, or 3. You never know. Just whatever the graph looks like. Make your decisions about multiplicities 1s, 2s, 3s. Build your factors with parentheses, and then I'll give you a random point which goes in for x and y to find your a value, and then check it on Desmos. You're allowed to use a graphing calculator. Check it on Desmos to make sure that the answer you turn in looks like, the original graph that's given on the test. All right, so we'll stop there and we'll continue all of this polynomials talk on Wednesday night.